Dear students, welcome to the class. So today's topic is phenols. In this session, we are going to discuss the Fries and claisen rearrangement with examples and conversion of phenol to phenolphthalein and fluoroscein. Now let's see what is Fries rearrangement. So here an aryl ester is transformed into a hydroxyaryl ketone with the help of a Lewis acid catalyst and an aqueous acid. Here you can see in the reaction an acyl group belonging to the phenolic ester, it migrates to the aryl ring and then it is ortho or para-selective, that is the acyl group attaches itself at the ortho or para position of the aryl ring. Now we will see the mechanism of Fries rearrangement. Initially, the carbonyl oxygen belonging to the acyl group forms a complex with the Lewis acid catalyst, and the bond between the phenolic oxygen and the acyl complex become polarized, generating an acylium carbocation. And this acylium carbocation goes on to attack the aromatic ring via an electrophilic aromatic substitution reaction. Generally, low reaction temperature favors the substitution at the para position, whereas relatively high temperature favors the ortho substitution. Next, let us see claisen rearrangement. Here, allyl vinyl ether is converted into a gamma delta unsaturated carbonyl compound when subjected to heat or a Lewis acid. This is what is claisen rearrangement. This reaction belongs to the sigmatropic rearrangement category of reaction, wherein the mechanism of reaction is concerted. So let me tell you what is sigmatropic rearrangement. A sigmatropic rearrangement is one where the sigma bond is changed to another sigma bond in an uncatalyzed intramolecular reaction. And then what is this concerted reaction? A reaction in which all the bond changes, that is, a new bonds are formed and the old bonds are broken. All these bond changes occurs in a single mechanism step. This is what is called concerted reaction. This claisen rearrangement can also be performed with allyl vinyl ethers. So this is the mechanism of claisen rearrangement. Here, the sigmatropic rearrangement of the allyl vinyl ether gives an intermediate dienone. And the resulting dienone now undergoes tautomerization to give its aromatic enol form. And this enol form is more stable than the dienone form. Thus, the required compound gamma delta unsaturated carbonyl compound is generated from the claisen rearrangement of allyl vinyl ethers. Now we will see the conversion of phenol to phenolphthalein. You know, phenolphthalein is used as an indicator in acid-base titration. It is a weak acid. It turns colorless in an acidic solution and pink in the basic solution. In fact, the synthesis of phenolphthalein is carried out by condensation of phenol with phthalic anhydride in the presence of zinc chloride. The phthalic anhydride formed reacts with the phenol in presence of concentrated sulfuric acid, and this is heated at 115 to 120 degrees Celsius for 10 to 12 hours and gives phenolphthalein. So next is the conversion of phenol or resorcinol to fluoroscein. So fluoroscein is an organic compound that has a wide application as a synthetic coloring agent or used as a dye. It appears as a yellow to dark orange or red powder. In fact, the fluorescent sodium is used extensively as a diagnostic tool in the field of ophthalmology. This was first synthesized by Adolf von Baeyer in 1871. So phthalic anhydride and resorcinol in the presence of zinc chloride forms fluoroscein via the French-Crafts reaction.